All right, this is the segment on adding integers. Now you need to remember that we have two essential rules for adding integers. The first rule states that if you are adding two numbers of the same sign, you simply add the numbers and keep the sign. That's how we first learned how to add when we were in elementary school. We said 2 plus 3 is 5. Because 2 is a positive number and 3 is a positive number, which gives us more positive numbers. Well, the same thing goes with our negatives. Remember, the negatives are just a mere reflection of your positive numbers. So if I have a negative 2 and I'm adding a negative 3, I'm more negative. So I add the 2 and the 3, and I still get my 5, but since they're both negative, my result is also negative. So one of our two rules for adding integers is that if I have a positive plus a positive, it's going to give me more positive. If I have a negative plus a negative, it'll be more negative. So if I'm adding two numbers with the same sign, we add the numbers and keep the sign. So what happens if I'm adding numbers that don't have the same sign? If I have 4 and I'm adding a negative 5, the 4 is positive because there's no symbol in front of it to tell us that it's negative. The 5 is negative because here's our little negative sign right in front. And I'm adding. So I have a positive number and I'm adding a negative number to it. When we have one of each sign, that is when we subtract the two numbers and keep the sign of what we call the larger number. Now the larger number is really the number that's further from 0. That's why they introduced the absolute value, which is a distance from 0. But pretty much in yours and my term, we can say, all right, if that negative sign wasn't there, which number is bigger? And with the negative not being by the 5, we know that 5 is larger than 4. So 5 is the larger number. The sign on the 5 is negative, which tells me that the result is going to be negative. And now I subtract the two numbers because I had one of each sign. So I look and I say, okay, if I had a 4 and a 5 when I was first learning subtraction, we wouldn't go 4 minus 5 because we were told that you don't take the larger number from a smaller number. So in my mind, I'm going to go 5 and I'm going to subtract the 4. And 5 minus 4 is 1. But once again, my answer is going to be negative because the sign on the 5 was negative. So 4 plus a negative 5 is a negative 1. Let's do another. Here I have a negative first. It's negative 6 plus 9. Now the 6 is negative, the 9 is positive because there's no other symbol in front. So once again, I have a positive and a negative. When that's the case, that's when we add or subtract the two numbers and keep the sign of the larger. So I look at it and say, okay, the sign of my larger number, this larger number is 9. The sign on the 9 is positive, so my answer will be positive. We don't write anything for that. And so then when I do my subtraction, I would go 9 minus 6 and get the answer of 3. Let's try another one. What if it was negative 8 plus 2? Once again, it's a negative and then a positive, so we subtract and we keep the sign of the larger. Which number is larger in this case? The 8. What's the sign on the 8? Negative. So my result will be negative. And then I subtract. 8 minus 2 is 6. So we have two rules for adding. Let me put them on the board. So when adding integers or any other real number, if both numbers are the same, you add the numbers and keep the sign. If adding one positive and one negative, subtract the numbers and keep the sign of the larger. only two rules for adding integers. Either they both have the same sign, or you have one of each. So you only have to know those two rules. Now, there's a whole different set of rules when you are subtracting integers, but we don't want to learn all these different rules because they get confused in our heads. So I think the addition rules are pretty easy to remember. If the two signs are the same, you add and keep the sign. If the signs are opposite, you subtract and keep the sign of the larger. That's a little bit easier to remember. So why do we have to learn new rules for subtraction? Well, what I like to implement is something I call the change. Now it has to be two changes. Right? The change. The first thing I'm going to do is I'm going to change my subtraction to addition. Now that would change my problem. If I had 4 minus 7 and I suddenly turned it into 4 plus 7, that would be a different problem. That's why we have to have two changes. So I'm going to change the subtraction into an addition. Now, the next thing I'm going to do is change the sign on the number that's after the subtraction. The 7 here doesn't have a sign in front, which means that it's a positive 7. So our original problem was this positive 4, and we were subtracting a positive 7 because there was no sign in front of that. So now that I changed the subtraction into addition, I need to change the sign on the number that's right after our subtraction. So the 7 is positive here, so I'm going to change it to a negative. So 4 minus 7 is now written as 4 plus a negative 7. Now I like to put the negative 7 in parentheses so that I don't lose that negative sign. And now I have an addition problem. Now I go back to my two addition rules. It's a positive and a negative. I subtract the two and keep the sign of the larger. So the larger number is the 7. The sign on that is negative, so my answer will be negative. 7 minus 4 is 3. So 4 minus 7 is negative 3. That's the change. Let's do another. What if I had negative 5 minus 8? The 5 is negative, we're subtracting, and the 8 is positive because there's no other sign in front of it. Remember, this is our subtraction. It's either a subtraction sign or we're calling it a negative, but not both. Right now, that's our subtraction. That's telling us what operation we are doing for this problem. So I'm going to do my change. So I change the subtraction into addition, and then I change the sign on the number that's after it. Always the number that's after, and that's the only number. So the 8 was positive, so I make it negative. So now my problem is negative 5 plus a negative 8. I have a negative plus a negative. When we have two of the same signs, we add the numbers and keep the sign. So the answer here is going to be a negative 13. Using change. So in both of those examples, we were subtracting positive numbers. What happens if we're subtracting a negative number? Let's do another. So let's have 6 minus negative 2. The 6 is positive, there's no sign in front of it. We are subtracting, and the type of number that we are subtracting is a negative. Once again, I go to my change. Because I don't want to learn a new set of rules for subtraction, I'm going to change them all to addition. So I change the subtraction into addition, and then the sign on the number right after it. The number right after is this negative 2. Since it's negative, I change it from a negative to a positive. So my problem, which was 6 minus a negative 2, now becomes 6 plus a positive 2. We don't usually put two positives in a row like that, and so I just cleaned it up and put 1. Now I see that I'm just adding these two numbers, and I get my answer of 8. So 6 minus a negative Subtracting a negative is the same thing as adding a positive. Subtracting a negative is the same thing as adding a positive. Subtracting a negative is the same thing as adding a positive. Let's do another one of those. So what if I had -3 minus a -5? So my first number is negative. I have a -3. I am subtracting, and the type of number I'm subtracting is negative. So once again, I have to do my change. Now, I never change the number that's in front. I'm changing the subtraction, and it's always the number that's right after the subtraction. So the subtraction becomes addition. This negative becomes a positive. So this now becomes -3 plus 5. So subtracting the negative became adding a positive. But now I have to say, okay, I'm adding, I have to go to my 2 adding rules. The adding rules say these are one of each sign. So I subtract and keep the sign of the larger. My larger number is the 5. 5 is more than 3. It's positive, so my answer will be positive. 5 minus 3 is 2. So instead of learning a new set of rules for subtracting, I do change. I change all of my subtraction into addition problems. Then you're adding a negative. Subtracting a positive is the same thing as adding a negative. Subtracting a positive is the same as adding a negative. So those are the 2 things you need to know about subtraction. Use your change method. Remember that subtracting a negative is the same thing as adding a positive, and subtracting a positive is the same thing as adding a negative. Now the multiplication and division of integers have the same rules. They are different than the adding and subtracting rules, but they at least share the exact same rules. So whatever holds true for multiplication also holds true for division. And the rules simply state that if we have a positive number times, and I'm using the raised dot to indicate multiplication, we don't use the cross for multiplication, a positive number times a positive number will give us a positive number. A negative number times a negative number also gives us a positive. So when we are multiplying and dividing, if we have 2 of the matching signs, it's always going to be positive. Now remember, this is for multiplication and division. Our addition rule says, oh, if it was a positive plus a positive, it'd be more positive, and a negative plus a negative is more negative. That's not the true for multiplication. Multiplication, if I have 2 signs that match, that's a good thing. That's what we're looking for. So 2 of the same thing is a positive. If we have a mismatch, if I have a positive times a negative, or a negative times a positive, if my signs don't match, that's a bad thing. So those results will all be negative. The same thing goes for division. A positive divided by a positive is positive. A negative divided by a negative is positive. Remember, division is really a fraction. And then the same thing goes if I have mismatch. A positive divided by a negative is negative. and a negative divided by a positive is also negative. So when multiplying and dividing, two of the same sign is a good thing. Or positive. A mismatch is a bad thing, so that gives us a negative. If we have several numbers being multiplied together or divided, what we can do is count the number of negatives. This one has 1, 2, 3, 4 negatives all being multiplied together. That's an even number of negatives. An even number of negatives will make your result positive. An odd number of negatives would make your result negative. And the reason for that is every 2 makes a positive. So this would be a positive and this would be a positive. And then you'd have a positive times a positive. So the answer here is a positive 5,040. If I only had 3 negatives, if this 7 wasn't negative, these 2 would make a positive, but a positive times a negative is a mismatch, and that's a negative. And then a negative times a positive would give us a negative 5,040. One of the most important concepts of this class is to understand what is a term. We will be using terms from this point forward in this class, and you really need to know how to identify a term and what we can and can't do with them. Now, the nice definition of a term is that it's a number, a variable, or a product of a number and variable or variables separated. Notice the E's are separated by the A's, and the correct spelling is separated by addition. Now, in order to be able to comprehend, we need to know what all the words in that definition mean. We know what a number is. A variable, remember, that's just our way of saying a letter. A variable is a letter. Or a product. Product. What's a product? Product in math land means multiplication. So it's either a number, or it's a letter, or it's a multiplication of a number and a letter. And one term ends and the next term begins because they are separated by addition. So here I have 17a plus 26b plus 14c minus 35. How many terms do I have? What are they? Well, let's see here. In this first portion, I have the number 17, and then I have an A. What's going on when I have a number and a letter mushed together like that? That's multiplication. Multiplication is a product. So this is all part of a term. And then I have, a plus sign. My terms are separated by addition. So one term ends because there's a plus sign. So 17a is one term. Then I have a plus sign, so that's starting my next term. My next term, here I have the number 26, that's a number. Oh, and a letter right after, once again, that means multiplication, so that's a product of a number and a variable. And then I have a plus sign, so that term ends. So my second term is 26b. And then I continue. I have a 14c that's being multiplied together, but then I have minus. It doesn't say anything up here about subtraction. Uh-oh. I don't know. Maybe that's all one term. Separated by addition. What do we know about subtraction and addition? Subtraction is the same thing as adding a negative. We have to do our change here. So this subtraction is really adding a negative. So 14C is another one of my terms. And I have a term at the end here, but the term at the end is negative. So it can be separated by subtraction as well, but if it's subtraction, we need to remember that the sign in front of the term goes with the term. Let me write that. The sign in front of a term goes with the term. I write that comment a lot on my algebra assignments. So that's another key thing. The sign in front of a term goes with the term. Let's make sure we get that in. So now we need to know what are like terms. A really bad definition would be to say, like terms are terms that are alike. But we need to be more specific than that. What are like terms? Like terms have two criteria. For most of this course, we're only going to be looking at the first criteria. But during the last week or so, we're going to be looking at the second criteria as well. So I want to make sure that I identify it now so we have the correct definition in our head and we can just make that next transition during the last week. Like terms have to have two things. The first thing is that the terms have to have the same variables. Remember, those are our letters, so they all have to have the same letters. And the second part, the variables have to have the same exponents. Let's remember the same thing as powers. Powers and exponents can be used interchangeably. They mean the same thing. So like terms have the same variables raised to the same powers. Now we're not going to be dealing so much with the exponents on things right now. That'll come later. So for example, if I have 5a plus 2b plus 3a, I have three terms up here. 5a is a term, 2b is a term, and 3a is a term. If the directions say to combine like terms or simplify this, we'd have to gather or put together the like terms. Only two of the terms are alike, because only two of the terms have the letter A. 5a plus 3a. Now we've identified that they are like terms because they have the same variables, so now all we do is add the big numbers in front. 5 plus 3 makes it 8, and I keep that A. 5 A's plus 3 A's is 8 A's. Now you aren't done though, because even though we don't have anything like this guy, he comes along for the ride. You can't lose a term in your answer. We've combined the like terms, but we still have this plus 2b. I can't go any further with that because A is not the same thing as B. So I'm all done. It is okay in math land not to have a single number for your answer. It's okay to have two terms like this as a final answer. Let's do another one. Here we have 6a minus 4b minus 9a minus 5b. What I like to do is underline my like terms so I don't get them lost or confused. So I start out, and when we put our answers, we always want the variables to be in alphabetical order. So the terms with A should go first, then the terms with B. And if I had terms that didn't have numbers, those always go at the end. So here's my 6A, and I'm looking for another A. Here's another A. But remember, the sign in front of the term goes with the term. So that's a negative 9A. I have a 6A and a negative 9A. So one of each sign I subtract and keep the sign of the larger. This will give me a negative 3A. The 9 is negative, and that's the bigger number. And then continuing on, likewise, here's a 4B. Oh, it's not a 4B, it's a negative 4B. And I'm adding to that a negative 5B. They are both negatives, so we add the numbers and keep the sign. To keep the sign, I can use that a subtraction instead of a negative sign, or instead of plus a negative. So that would be a negative 9B. You can't go any further because this term has an A, that one's a B, that's not like. Another key component is the distributive property, also known as the distributive law. This is saying that I have a number on the outside of your parentheses and I have more than one term inside the parenthesis. Now we can't simplify what's inside the parentheses because one of the numbers inside is a variable. I don't know what x represents, so I can't add 3 to it because adding 3 to something that we don't know would give us a different result. Now sometimes we like to say, oh, well, that's the same thing as 3x. Now remember, 3x means 3 times x. Adding 3 is not the same thing as multiplying by 3. You get a different result if x was 1 here than if x was 2, 3, 7, or negative numbers. So we can't simplify what's inside here. And we do know, though, that the parentheses also mean multiplication. So the number in front is being multiplied. Well, in order to actually simplify this, because we will need to break this down and get it into simplified terms, find out exactly what I have, we have to do that multiplication. And the way around the fact that we can't simplify what's inside the parentheses is we use what's called the distributive property. The distributive property says that you take the number on the outside and you distribute it or multiply it to every term inside the parentheses. So my first term is the x, so I'm going to take 2 times x. And I can't take 2 times x because, once again, we don't know what x is. So that just becomes 2x. We mush those together to indicate that they are being multiplied. And then we have to take the 2 times the 3. We are still adding, so you need your plus sign, and 2 times 3 is 6. And that's your result there. We're not solving anything, there's no equal sign. This is simply doing some simplification, getting rid of our parentheses. Let's do another. 4 times the quantity of 2x minus 5 is how this would be stated. Once again, I cannot simplify what's inside here. This has an x, this one does not. But I can distribute the 4 inside. So I'm going to take the 4 times this first term. Now I can take the 4 times 2, which is 8, and then that result would be taken times the x. And then I take the 4 times the subtracting the 5. So I'm still subtracting. 4 times 5 is 20. That's as far as I can go on that problem. Let's do one with a negative. Negative 6 times the quantity of 3x minus 7. Now we have to remember our rules of multiplication. So 3x is positive, the 6 is negative. If I take a negative times a positive, I get negative 18x. Now here's a subtraction. Once again, you might want to say, oh, that's adding a negative. So it's a negative 6 times a negative 7. Negative times a negative makes it positive. You need the plus sign to separate your terms. And 6 times 7 is 42. That's our final result. Hopefully after a while you won't need to do the change, and you'll recognize that the sign in front of the term, because it's a subtraction, means that that number is negative. And a negative times a negative would make that a positive. All right, now the next thing we have, and the last thing for this chapter, is to solve two-step equations. An example of that would be 4x plus 2 is equal to 14. Now the reason why this is considered a two-step equation is because we have a single number over here, but on this side we have two operations. The 4 is being multiplied with the x, and then that term is being added to this other term. So we have two mathematical operations, and we have to undo both of them in order to get x by itself. So we think about order of operations, and that's what messes us up when we're solving equations. Remember, this has an equal sign, which means that we are now at a balance. The left side is equal to your right side. So whatever I do over here, I have to do the same thing on this side. Because we are undoing the actual mathematics, we do the order of operations in reverse twice. What do I mean by twice reverse? Well, not only are we going to do in the opposite order, but it's the inverse operation. Inverse operations cancel each other out. If I take 2 steps forward, I have to take 2 steps backwards to get where I started from. They undo each other. Adding 2 and taking away 2 puts me back where I started from. So those are called inverse operations. Multiplication and division work the exact same way. 2 times 3 is 6. 6 divided by 3 brings us back to 2. They undo each other. So when I have a problem like this, I need to undo my steps. So the first thing I look at is for any addition or subtraction, because I'm going to try to get the term that has the variable by itself. Notice I have 3 terms up here. 4x is a term, 2 is a term, and then on the other side of my equal sign, I have another term of 14. 2 of those terms would be what we call like terms, the 2 and the 14. Neither of them have a variable attached to them. So I want to get the terms that are alike together, and I want to get them away from the term that they're not like. Okay? So the 2 and the 14, neither of them have a letter. Here's the term with a letter. We want to go away from there, so I need to move the 2 onto the other side of the equal sign. Remember, the equal sign separates the pans in our balance. So I want to move the 2 to the other side. But if I'm adding 2 over here, it's not the same thing as adding 2 on this side. I have to do the opposite to keep things balanced. Okay? So what we're going to do, as we learned last week, is to cancel out addition, we subtract. So I'm going to subtract 2 from here, and whatever I do to one side, I have to do the exact same thing to the other side of the equal sign. Adding 2 and taking away 2, those are opposites, which always gives us 0. That's what we want, because 0 plus anything is anything. And then I have on this side 14 minus 2, which gives me 12. So then our second step is to get the 4 away from the x. Remember, when a number and a letter are mushed together, it means multiplication. So to cancel out multiplication, we divide. We show division by drawing a fraction bar. That's 4x divided by 4. Once again, whatever I do to one side, I have to do the exact same thing to the other side to keep it balanced. 4 divided by 4, any number divided by itself, is 1. 1 times x is x, because 1 times anything is anything. And that's how we get x by itself. On the other side, we have to do the division, top number divided by bottom. 12 divided by 4 is 3. So x is, or x equals 3, is the solution to this equation. Remember, the first thing we did was add or subtract. The second thing we do is divide. Let's do another. Now this one's going to be a little bit harder because we have negatives. It's 2x minus 9 is equal to a negative 23. So we have to remember all of our rules for adding, subtracting, multiplying, dividing with positives and negatives. Once again, the first thing that we want to do is get the 2x by itself by removing the 9 from the left side and moving it to the right side. It's subtracting 9, so to cancel out subtracting or taking away, I give 9. So I'm going to add 9. Whatever I do to one side, we have to do to the other side. Notice how I nicely lined up my numbers. Now we have to remember our adding rules with positives and negatives. I have a negative and I'm adding a positive. One of each sign we subtract and keep the sign of the larger. 23 is larger than 9, so it's going to have a result that's negative. And now I have to take 23 and subtract 9. That gives us 14. Our second step now is to get the 2 away from the x. We always do that by dividing. Once again, what I do to one side, I do to the other side. The 2's cancel out, giving me 1. 1 times anything is anything. And on the other side, I have a negative divided by a positive. When multiplying and dividing, a mismatch is a bad thing. So this is going to give me a negative 7. So x is equal to negative 7. So once again, for solving our two-step equations, the two-step equation, the first step will always be to add or subtract. The number without the letter. Always add or subtract the number that's without the letter when we have these two-step equations. That will give the term with the variable all by itself. So then our second step is to get the number away from the variable. So the second step will be to divide both sides by the number in front of the letter. And that's how you solve a two-step equation for this week.